Okay, so today, gentlemen, we are going to be discussing fossil fuel formation, and we kind of talked about it on every day when we talked about the fossil fuels, but today we're actually going to demonstrate and illustrate it. And I already know that you're all in counseling because you're not as good as me with the drawing. So once again, your homework, you only need to study your notes today. Do not take that for granted when I say study your notes, because some of you don't, and then you have an assessment and you do horrible. So make sure you study your notes. All right, so let's go ahead and get started. Your notes, you got a blank sheet of paper. You want to turn your paper the long way. So turn your paper so that the holes are like this. Okay. Now, in talking about fossil fuel formation, again, this obviously means how our fossil fuels form. From your knowledge of what we talked about yesterday and the day before, who can give me like a generalization or some information on how fossil fuels are formed?
Beneath the earth, and beneath the earth by millions of years. Millions years of age of fossil fuels.
Okay, so let me ask you this. If I said, because this would be the question, what happened? Now I'll give you the answer because you're giving me fragmented pieces. Keelan, I said.
There remains of plants.
No. I don't want to know what it is. I'm asking you what happened. If I said, what happened yesterday, and you said, there are stores and people, do that make sense? No. So, fossil fuel formation, how did they form? What happened? How did not fossils, fossil fuel. And fossil fuel, first of all, let's back up. Hold on. Let's back up a little bit more. What are fossil fuels? You say, isn't it like we haven't been talking about it all week? Elijah, another shot. Obviously, because it has the word fossil fuel, but what if I don't know what fossils or fuel is?
It's energy.
Okay, energy, that's the fuel. Tim?
Fossils are sometimes like decay.
Okay, excellent, Tim. What he did was he made a definition of this word. So fossils are decayed animals and plants. Remains. So it is the remains of plants energy, which is the fuel. So that fossils are the remains of ancient plants and animals that create energy. How? How did they form? That's the formation. How did it create energy? How did it form, Brittany? Okay, the heat and pressure of the earth changes the fossils to natural gases. Are natural the only fossil fuel?
No.
Okay. Natural gases, comma, oil, comma, and
Petroleum.
that is oil,
Coal.
coal. But how? In order for something to be a fossil, what had to happen? First of all, it is the remains of plants and animals. They were alive and they died. So plants and animals died. Then what?
Came back alive.
Please no. They died. Then what? They decayed into the what? Into the world, into the earth, into the ground, into the soil. This, in case you didn't know, this means world. Sign language for world. You have a circle, you have a W. This means world. Okay, so they decayed into the ground. And then, now what Brittany says, the pressure and heat of the earth changed them into natural gases, comma, oil, comma, and coal. And that's exactly what this demonstrates here. And it's not just the plants and the animals of the Land, it's also the plants and the animals of the
Earth.
that is the land,
Water.
ocean, the water. All right, so this just demonstrates exactly what this is here, and what we're going to do is we are going to go ahead and draw it out. So you should have titled, again, your paper up here, fossil fuel formation. I'm not going to rewrite it because it was already on the first page, and this paper is at a height of 8 foot, and I can't reach it because I'm 6'2".
Oh, I see.
You got 6'2", you like 5.
All right.
That's all.
I'm like 2 feet taller than Tamersi.
No, you're not.
Oh, okay, more like 4 feet. Actually, you know what? I am going to write it, but mine is going to be more right here instead of at the very top, because I do need to write some more information under it. So we're going to write fossil fuel formation. And that's the title of these notes. Now, for fossils, our notes are not going to be our generalized way that you have bullets and this and dots, because we're drawing pictures. We're going to have words next to pictures, but you have this illustration of what it is that we are talking about. So, we said that fossils are prehistoric what? Animals and plants. Prehistoric plants and animal, you said it, remains from yesterday? How much long ago? Last year? From millions of years. And that wasn't millions of years.
Who said that?
That's 2,000 years. Yeah.
There we go. Fuel is what? Energy or power. And energy or power does what? Makes things what? Go. Makes them work. So, now fossil fuel formation, let's break it back down what we just recently said. And Brittany added, and Madison added some, Miracle added some, Elijah, Keelan added some. What is fossil fuel formation again?
Prehistoric. How fossil?
Okay, so materials, or what did we say? Give me your words that you said. I don't exactly remember.
Ancient.
Okay, keep going.
Prehistoric.
Give me the whole thing.
Oh, prehistoric plants and animals remain from millions of years ago.
That's what fossils are. Oh no, fossil fuel formation.
That is not giving us fuel.
Huh?
That is not giving us fuel for energy.
Give me the whole thing.
Ancient plants and animals that decayed over million years ago that caused fuels to energy of power.
Brittany, add in, chime in anytime, because you said the very important portion.
Ancient plants and animals that died from, what's that word? Not decayed, the other word.
Which word?
Ancient plants and animals that decayed and over millions of years, the earth's pressure and heat changed them to natural gases.
Okay. You said the earth's what did what? You said the earth's, huh? Heat and pressure. That's the most important things. So fossil fuel is a material, and the material that we talked about were, what are fossil fuels? What are those three materials? Oil, natural gas, and coal. So we're going to write now, we already have a definition for what those are, but I'm keep saying it so that you know. We have those in our notes. So right now, we're going to call them materials. materials created from prehistoric organism remains, and organisms are what? Plants and animals. Good job, Celeste. It's created from prehistoric organism remains that, let me put these into words, that where, hold on, don't write yet, I'm trying to put it in. Prehistoric organism remains okay, now you can write. Materials created from prehistoric organism remains where the Earth's heat and pressure was used to supply energy, and that energy does what for us?
Give us heat and light.
For energy to heat homes, and instead of homes, we're just going to all right? So you have the coal. Our next formation, what other type of fossil fuel do we have?
Natural gas.
Formation of gas and oil. And I put them two together because remember the gas comes from the oil. Now, this happens where?
Under the ocean.
In the ocean. So in order to have the ocean, we must have an ocean what?
Floor.
We have an ocean floor. And ocean also consists of water.
So gas and oil are produced the same way?
Well, gas comes from the oil. And in the ocean, we also have what? Fish. Or other organisms. So not only do we have fish, but we also have, not only have animals, we also have plants. You're not an artist, so you wouldn't know. This is an ocean with the ocean floor, plants, and fish. Anybody could see that if you have an artistic eye.
Yeah,
I know, because you don't have an artistic eye.
I can.
All right, time goes by throughout your 300 to 400 million years. What happens? We still have our ocean floor. I'm just going to draw that here. But over here, what happens to our organisms? They die. And even our plants die. And they do what? They decay into the
Ocean floor.
ocean floor. So then on our picture here, we now have our dead organisms. Same thing like on Earth. We have new layers of land because we learned from continental drift that some areas that used to contain water, maybe over millions of years, happened what? They dried up. They didn't contain water anymore. So then we have another layer of land. We have a layer of rock. We have, That's another layer of land. A layer of the ocean floor. That's the projection. Then you have another layer more. I'm just not going to draw that much more. But then again, time changes, so this may become another ocean. And this, let's say over 50 to 100 million years, all this layering happens. But then we go to what happens today. We still have our floor down here. That decayed plants and animals because of heat and pressure. What happened to those organisms? They turned into what? What are we talking about? What type of fossil fuel? Oil. Not natural gases, because we make natural gases from oil. This is now oil. And that oil is underneath this layer. We also then still have this layer along with this one. And we have our ocean. And we build these things called oil rigs. Which drills down into the oil. And this will be an oil rig. And it spews out our oil. And that's how that happens. Any questions with that? Does this give you a better illustration and understanding of how this works? Okay. An oil rig. Rig's oil. I want you to flip over to the back when you're finished that. We're going to just copy down a couple other things really quickly and move on from there. Huh? No, you can turn it whatever way you want. You could put it regular way, this way, or you can keep it this way. But what you're going to do is just draw a line down the middle, whether way you're doing it, because we're going to have fossil fuel negatives and alternatives. Can I take this down? And it's okay if you write big, because we're only writing a little bit, so you can kind of make it big so you can see it. Can I move this down? No, I'm taking it down because I need this space. I can't because I need this whole space. All right. So on your left-hand side, you want to write fossil fuels negatives. On the left-hand side. Now, although these fossil fuels come from the earth, and it's a natural resource, it does have some associated negatives. You think about it. We're drilling down in the earth and we're spewing up the stuff. How many of you have ever been at the gas station and that smell of that gas? Now, some of you may like that smell, but it is dangerous.
I like that.
Stop it. And that is a what? It does what to the air? It pollutes the air. So one of the negatives is pollution. You want to write that? Do we need to put pollution as harmful? No, because we already know the term pollution means harmful. It contributes to what?
The greenhouse.
Greenhouse effect, because it emits what into the air? You just carbon dioxide. So you want to add that. Contributes to the greenhouse effect because it emits carbon dioxide into the air. Contributes to the what, everybody? Greenhouse effect because it emits carbon dioxide. Now, I hope you only put that on the left side, not anything in the middle. Okay. And basically what you said is just this. I didn't want to put this up here because I don't want you guys writing all of this because you just put it in your own words. What is the greenhouse effect? That contributes to the global warming, which does what? What is the greenhouse effect, though? An increase of what?
Carbon dioxide.
Carbon dioxide in the earth, which then contributes to global warming, which is doing what to the earth? Heating up the earth, which depletes our, not our ice cap, our thing that protects us, our ozone layer. If our ozone layer is damaged, that allows what to get to our earth? UV rays, which come from the sun. Very good. It is. On the right-hand side of your paper, I want you to put alternatives to fossil fuels. On the right-hand side, put alternatives to fossil fuels. Alternative means what? Something besides. Now we understand, and one alternative is nuclear fission, so I want you to put that underneath there. But we do understand that although fossil fuels are a natural resource, it's non-renewable, which means what? It's not going to be back in our lifetime, so it's a possibility that if we're using them to heat up our homes and our cars, what could happen to it? We could run out. So we need an alternative. So scientists have come with an alternative. This alternative is nuclear fission. Now, in our world, we do understand from chemistry there are multiple other what? Elements. In the element, there are other elements that can provide us with energy. These two elements are plutonium and uranium. So nuclear fission is actually the splitting of the nucleus of these two elements that provide us energy. So basically, splitting apart heavy elements, those heavy elements are uranium and plutonium, to release energy. Because we don't want to overuse our fossil fuels, so we have an alternative that is going to still release energy. That's what nuclear fission is, splitting of heavy elements, and in this case, we're talking about things like uranium and plutonium.
Fossil fuels are renewable, right?
Non-renewable, because again, they cannot be replaced in our... The positive thing to this is it is not going to submit carbon dioxide into our air. So it doesn't produce carbon dioxide when it is used.
Is it harder to produce when you do the nuclear?
It's still difficult, yeah, but it is an alternative. Fission. Although it has a positive, just like fossil fuels have a positive, it also has a negative. One of the negative is it could cause a nuclear meltdown. A nuclear meltdown means that it overheats the core of our Earth, and it could damage the core of our Earth.
Gravity. Wait, wouldn't that mess with gravity? So we would be floating?
No.
Yeah.
We would die, our Earth would overheat.
Oh, I was saying, really space, like...
Because if our core is too hot, It heats, start heating on the outside all the way through. Yeah.
Oh my God, what if we did float?
Everyone have this?
We can't even get knocked out. We get knocked out.
You have this? Once you're done writing this, we're done writing for our notes, and we're just going to kind of review our homework a little bit and talk about some alternatives.
Yes.
Are we good? Yes. Yes. We straight? Troy. Yeah, wait. Alrighty. I'm good? You good, Maggie? Okay. So there are conventional ways of getting gas, and then there's alternative ways of getting not gas, energy. Conventional, basically, from this paragraph here. Actually, let's read it, and then you tell me what conventional alternative are. I know reading, you hate it, but hey, guess what? You need to do it. So, Chappie, without further ado. Yeah, I'll zoom it in for you. Don't worry about it. We can fix that for you. She's blind, so we'll fix it. Here you go, Chappie. Look at that. Look at God.
Conventional. The use of conventional technology to produce electrical power normally results in pollution that affects everyone, and it often relies on the burning of fossil fuels that produce dangerous gases that often end up in the atmosphere. People and animals breathe in the polluted air, and plants absorb the pollution. Large amounts of electrical power can be produced through the use of conventional technology. Because of our large towns and cities and large populations, many believe that conventional technology is the only way to produce enough electricity for us all.
So what is conventional?
Large amounts of electrical power.
Which means, is this something that we use sometimes, or this is something that we use all the time? Conventional is all the time versus alternative, which, go ahead and read that for us. Malik.
Alternative energy is normally produced by harnessing the natural world around us and the elements. Usually, it does not create pollution in the atmosphere, or at least it only produces small amounts. At present, alternative energy only provides us with small amounts of electrical power, and much investment is required to increase the amount of electricity produced in this more natural way.
Thank you. All right. So now we're going to look at some ways that we get energy, and then you're going to tell me, is this conventional or is this alternative? Alternative is what? Another way. All right. First one. Hydropower.
Alternative.
Alternative? What's hydro? Water. Getting power from water. Like Niagara Falls area. So this is alternative. We don't normally do this. Good. Natural gas. Conventional. I was waiting for it. Alternative.
Conventional.
Heat.
Alternative. Alternative.
This is conventional. Remember, what is heat? Decay. Partially decayed organisms. Wave power. Alternative. This is also hydropower. Conventional. Here's a question. What is biofuel? Raise your hand and tell me, Chappie.
Bio is life, so fuels that we produce.
Just us? We're the only living things? How selfish of you. Okay, so then what are you saying this is?
I say that is conventional.
Conventional.
Yeah.
Who said alternative? It can be true too, because biofuels, it does come from plants and animals, which we have old fossil remains that we've used to make coal, and oil. However, some people use the dead plants that have just died to be able to recreate some type of energy for certain things like cars and things of that nature. So some people have been able to use urine to be able to produce power, and that is a bio because that's from life. So it's both conventional and alternative. All right. Wind power. Alternative. Nuclear energy. Alternative. We just talked about nuclear fission. Tidal power. Alternative, because this is also a hydro. Good. Oil. Conventional. Very good. All right, now I'm going to introduce you to a song. And if you're watching this video online, then you are going to just watch the song down below.